Part 3 of chapter 16 starts from section 4, efficiency in production, right? Section 3 was efficiency in consumption or efficiency in exchange. The last part of section 3 was second theorem of welfare economics, right? So for example, at any point is Pareto efficient point in this HOS box, right? For example, so production, anyway, first efficient outcome occurred at the market at this point. But people think that this point is more equitable point. Then after reaching at this point, we can move to this point, right? This one to this one by redistribution. That is second theorem of welfare economics. But sometimes moving from here to here is costly, right? That is the last point of section 3. Okay, now we go section 4. Efficiency in production, input efficiency. I already explained input efficiency or technical efficiency. The condition under which firms combine inputs to produce a given output as inexpensively as possible. So a particular allocation of input, labor and capital into the production process is technically efficient if the output of one good cannot be increased without decreasing the output of another good. If input markets are competitive, a point of efficient production will be achieved. If the labor and capital markets are perfectly competitive, then the wage rate, W, will be the same in all industries. Likewise, the rental rate of capital, R, will be the same whether capital is used in the food or clothing industry. Right? So what is the point of this one? Now we're back here. So this HOS box, I already explained this HOS box. At this point, right, that is, for example, this point, that is isoquant for 80 unit production of QF is 80. There are lots of labor and capital combination to produce 80 food, right? That is this one. And what is this blue one? Blue one means production of clothing is 20. Labor and capital combination to produce 20 clothing. Okay, that is isoquant for Q2. And at this point, two isoquants tangent with each other. That means slope of this one is MRTS for food production. Should be equal to slope of indifference curve of Q2, isoquant Q2. That means MRTS, labor for capital for clothing production, same. Right? That is input efficiency in input, or technically efficient point. Right? And also think about input efficiency in competitive market. Competitive input efficiency. What's the meaning of this? This one means, now think about, there is some price line, right? What is this price line? This price line is equal to this one. So now think about W, wage rate, multiplied by F, plus R, K, F, should be equal to cost, isn't it? Right? Then rewriting this KF is equal to C over R minus W over R LF. Can you remember this? That is a cost function in cost minimization problem. Minimizing cost, right? Subject to QF is equal to 80, for example. There are lots of ways to produce 80 units of food. Lots of labor and combination to produce 80 food, right? But you want to produce 80 units of food with minimized cost. Actually, this straight line is this isocost line. So at this point, you know, condition, cost minimization condition is slope of isoquant, slope of isoquant is MRTS, labor for capital for food production, is equal to W over R, slope of isocost line, W over R, isn't it? Right? Also, now think about this one. Clothing production. You want to produce 20 units of clothing subject to cost. That is WLC plus RKC is equal to cost for clothing. Right? Rewriting this, KC is C over R, W over R, LC, and QC is 20 units. Right? Cost minimizing condition of this one is equal to MRTS, labor per capita in clothing production is equal to W over R. Right? Factor market is also perfectly competitive. So the slope of isocost line in producing clothing is perfectly same to that in food production, right? So this condition satisfied cost minimization problem. So in food production, cost minimization condition for clothing production satisfied simultaneously. So at this point, there are four curves tangent with each other, right? That is input efficiency in competitive market or competitive market equilibrium in production. Can you understand? Only this one means input efficiency, right? This one is equal to W over R, right? That is competitive equilibrium. Okay, now we're back to slide number 31. Input efficiency. From chapter 7, we know that to minimize production costs, producers will use combination of labor and capital so that MPL over MPK, that is MRTS, is equal to MRTS food is equal to W over R. And MRTS for clothing, right, is equal to W over R. Because the MRTS is the slope of forms isoquant, the competitive equilibrium is efficient in production, right? Nothing new. Also, next slide is production possibility frontier. I already explained this one in section 3, right? So, production possibility frontier is curve showing the combinations of two goods that can be produced with fixed quantity of input, right? So, so from here, this contract curve in Edgeworth box can be converted, transformed into production possibility frontier. I already explained, right? So the production possibility frontier shows all efficient combination of output QF and food production and clothing production. That is figure 16.9. The production possibility frontier is concave because its slope increase as production of food increase. We moving this way. So MRT, slope of production possibility frontier is MRT, isn't it? MRT increase and increase, right? So marginal rate of transformation. Marginal rate of transformation, amount of one good must be given up to produce one additional unit of second good. When the MRT is very low, so it's the ratio of marginal cost of producing food to marginal cost of producing clothing, MCC. In fact, MRT, the slope of the production possibility frontier measures the marginal cost of producing one good relative to marginal cost of producing the other. At every point along the frontier, the following conditions satisfied. MRT is equal to MCF over MCC, okay? So, okay. From this Edgeworth box, right? Satisfying these two conditions. We can draw production possibility frontier, QF, Q clothing. So at this point, food production is very small, clothing production is very big, right? So this point means here, this point means this one. Connect all of this contract curve in Edgeworth box, we can get this kind of production possibility frontier. MRT is a slope of production possibility frontier, right? So MRT moving from this way, MRT increase and increase and increase. Slope of production possibility frontier. That is MRT, right? MRT increase and increase. So MRT is equal to MC food divided by marginal cost of clothing production. We're moving this way. More product. So we know that. So in partial equilibrium analysis, we know that marginal cost curve increase, like this. For example, food production increase, then marginal cost increase, right? So we moving this way. When we moving this way, what happens? Production of food increase, production of clothing decrease, right? So moving here to here to here, then marginal cost, this one, increase and increase and increase as you're moving there, right? Movement from here to here means production of clothing decrease and decrease. That is marginal cost of clothing. We moving clothing production decrease and decrease and decrease, right? Then what happens? Marginal cost decrease and decrease. That means marginal cost of clothing decrease and decrease and decrease. So MRT increase and increase as we moving from left to right side, right lower side, right? That is explained in slide number 33. And MRT is equal to MCF over MCC, equation 16.3. Now, we can define output efficiency. Then, what is output efficiency? Right? Output efficiency. That is slide number 34. For an economy to be efficient, goods must also be produced in combination that match people's willingness to pay for them. The marginal rate of transformation measures the cost of an additional unit of food in terms of producing less clothing. An economy produces output efficiency only if for each consumer MRS is equal to MRT. That is output efficiency, equation 16.4, right? So here, we introduced production possibility frontier from adjust box, right? So QF, QC is like this, right? That is PPL, right? PPL. And in one country or one individual, we can define indifference curve. Look at that, indifference curve, right? In adjust box. For example, utility of James in the adjust box in section 3. Then, like this. For example, like this. That is indifference map or one indifference curve. How can I say? Indifference curve of James. Like this. One guy is like this. Output efficiency set PPA tangent with indifference curve of one individual or one country, right? For example, at here we know that this point. Now think about this point. At this point, what happened? Production possibility frontier tangent with this one. Anyway, one country or one individual, right? So production should be occurred one point on this production possibility frontier, right? And want to touch highest indifference curve. So maximize after production, reaching at high level, some utility level, highest utility level from the consumption of both goods, right? Consumption of both goods. That occurred at this point. Can you understand? Why? If you production occurred at this point, you can draw indifference curve crossing this point. Then it should be like this, right? If you choose this one, indifference curve is like this point, like this one, like this. So, we moving this way, you can touch higher indifference curve. Also, when reaching at this point, you can touch highest indifference curve. Okay? Now you're starting from here. You choose this point as your production, then what happens? Indifference, utility level is this one. How about this? Utility level is this one. Utility level increase. This point, increase. And finally, at this point, A, utility level maximize. Right? So that is, we said this is a output efficiency, where tangential two curves, PPF and indifference curve or utility curve, right? Indifference curve or utility curve. Mathematically said, that means at this point, slope of two curves same, right? Slope of production possibility frontier is MRT, right? Food for clothing. That is opportunity cost of food in terms of clothing from the perspective of production, right? Relative cost of food production in terms of clothing, right? So exchange rate from the perspective of production. And slope of indifference curve at point A, that is MRS, food for clothing. What is this? That is a relative price of food in terms of clothing evaluated by individual consumers, right? So exchange rate food for clothing from the perspective of consumption or how consumers, that is exchange rate of food in terms of clothing from the perspective of production. This one is equal to this one. That is output efficiency. Can you understand? Right? That is definition of output efficiency. Right? Now then, think about what is output efficiency in competitive market or competitive output efficiency. Competitive equilibrium says there exists a market. Right? So, now think about this. What is this? Right? So, at this point, in consumer theories, for example, James or one individual maximize utility of James from consumption of food and clothing, subject to budget constraint, right? Budget constraint is C is equal to what happened? Income over PC minus PF, PCF, right? Consumer theory solve this kind of problem, right? So consumer utility maximization condition is slope of indifference curve, MRS, food for James, food for clothing, right? For James should be equal to slope of budget constraint, that is PF, PC, right? This one, that is budget constraint, and you want to solve touch highest indifference curve, that solve this one, and we know that this, right? Also, you studied the value maximization problem in production theory. What is value maximization theory? Maximization of value of two products. Value of two products, PF, QF plus PC, QC. Rewriting this, QC is equal to value over PC minus PF over PC, QF, subject to PPA, production possibility frontier. Right? What's the meaning of this? Production should be occurred 1 point on this PPA, and you want to touch highest ISO value line. What is ISO value line? That is GDP, simply talking. When there exists two goods, food and clothing, value of two products, that is GDP. Maximizing GDP subject to PPA. What is equilibrium condition for this? slope of iso value line is equal to PF over P3. Should be equal to slope of PPF. That is MRT. Right? MRT for clothing. That is value maximization condition. That is utility maximization condition. Equilibrium condition from the perspective in consumer theory. That is maximization condition, value maximization condition in production. So then what happened? Combining this one is MRS is equal to, what is this? That is relative price of food in terms of clothing consumer face at the market. Right? PF over PC. This one is also same to this. This one is relative price of food in terms of clothing producers face at the market. After production, they sell at this price. Right? That is, so this price, market price, consumer face is equal to market price, producer's face. Should be equal to MRT. That is output efficiency in competitive market condition. Can you understand? Also, our textbook, there are two ways. This one is same. This one is more easier explanation of this one, value maximization. Right? That is value maximization from the perspective of society. Now think about profit maximization condition. Right? Profit maximization condition is same to value maximization condition. Market is perfectly competitive. Food production and clothing production, right? Then, when market is perfectly competitive, profit maximization condition for food production. What is this? PF should be equal to marginal cost in food production, isn't it? That is profit maximization condition for food production, right? And think about profit maximization condition for clothing production. That should be equal to P3 is equal to MCC. Marginal cost in clothing production, isn't it? So this one divided by this one. Then we can get PF over P3 is equal to MCF over MCC. We get this kind of thing. And we know that this one is perfectly same to equilibrium condition for value maximization. Right? This one and this one is perfectly same. Right? So we can derive this one from value maximization condition or profit maximization condition of two goods. Anyway, combined with utility maximization condition, we can get this one. Right? That is output efficiency when in competitive market. To see why, so MRS is MRT. To see why this condition is necessary for efficiency, suppose MRT equals 1, while MRS equals 2. What's the meaning of this? Opportunity cost of Q1 in terms of, from the perspective of producers, one food is equivalent to one clothing. But MRS is equal to 2. From the perspective of consumers, one food is equivalent to two clothing. In utility maximization process. In that case, consumers are willing to give up 2 units of clothing to get one food. But the cost of getting the one food is only 1 unit of lost clothing. Clearly, too little food is being produced. To achieve efficiency, food production must be increased until the MRS falls and the MRT increase, and the 2 becomes equal. 2 are equal. Okay? The outcome is output efficient only when MRS equal to MRT for all pairs of goods. Okay, so graphically like this. Output efficiency. The efficient combinations of output, right, food and clothing, is produced when the marginal rate of transformation between the two goods is equal to the consumer's marginal rate of substitution, which measures marginal benefit of consuming one good relative to the other. Right? So production possibility frontier and indifference curve tangent with each other. Okay? That is output efficiency. Efficiency in output market. When output markets are perfectly competitive, all consumers allocates their budgets so that their marginal rate of substitution between two goods are equal to the price ratio. So I already explained that MRS equal to PF over P3. That is utility maximization condition, equilibrium condition for utility maximization, isn't it? Okay? Now, at the same time, each profit maximizing firm will produce its output up to the point which price is equal to marginal cost. Again, for our two goods. So PF is MCF and PC equal MCC. From here, we can derive MRT, MCF over MCC is equal to PF over PC. Right? From the equilibrium condition for from the perspective of producers. Right? So combining this one and this one, we can get output efficiency. MRT is equal to PF over PC is equal to MRS. Right? So MRT is an exchange rate of food in terms of clothing from the perspective of production or producers. MRS is exchange rate of food in terms of clothing from the perspective of consumers. PF over PC is exchange rate of food in terms of clothing at the market. These three equalize. Right? Then we say efficiency in output, competitive output market. Okay? Competition and output efficiency. In a competitive output market, people consume to the point where the marginal rate of substitution equal to relative price, PF over PC, in other words. Producers choose output so the marginal rate of MRT is equal to relative price. Right? We already studied this. Because the MRS equals the MRT, the competitive output market is efficient. Competitive output market is efficient, led by market or price. Any other price ratio will lead us excess demand for one good and an excess supply of the other. Right? That is output efficiency. So Adam Smith's idea is just this point. All the economists can reach at this efficiency point from the production and consumption and output. Right? Achieved at this point automatically only when market is perfectly competitive. If market is perfectly competitive, we can reach in this output efficiency point. Or, and at the same time, input efficiency point. Also at the same time, exchange efficiency in consumption point automatically. That is Adam Smith's idea of individual overhead, and that is a philosophy of market economy, actually. Okay? Okay, section 5 skipped because we studied this in another lecture of mine or Professor Hyun's International Trade Theory. Okay? Then we go section 6, an overview the efficiency of competitive market. So summarization of efficiency of competitive market. In other words, market is competitive market. If the market is perfectly competitive, all sorts of efficiency achieves automatically. Okay? During our analysis of general equilibrium and economic efficiency, we obtained two remarkable results. Number one, for any initial allocation of resources, a competitive process of exchange in input or output market will lead to a Pareto efficient outcome. Okay? We refer to this outcome as the fourth theorem of welfare economics. Right? And the second theorem of welfare economics tells us that under certain conditions, admittedly ideal, issues of equity and efficiency can be treated distinctly from one another. If we are willing to put the equity issue aside, then we know that there is a competitive equilibrium that maximizes consumers and produce surplus. Is economically efficient. That is the idea of Adam Smith of market economy, isn't it? Unfortunately, neither of these results necessarily holds when for some reason markets are no longer competitive. This result holds only when market is perfectly competitive. Below, we list the conditions required for economic efficiency in exchange. Efficiency in exchange, right? And we studied also efficiency in import or production, right? Input market, efficiency in input market or production, right? And efficiency in output market, right? Efficiency in output market, right? So efficiency in output market, we studied in the last part of part 2. That is, what is this? MRS, food for clothing, is equal to MRT, food for clothing, right? Efficiency in exchange said, what is this? Efficiency in exchange is MRS, food for clothing of James is equal to MRS, food for clothing for Karen, right? That is efficiency in exchange. Efficiency in production or input market is, what is this? MRTS, labor capital for food production is equal to MRTS, labor per capital in clothing production. Okay? So, efficiency in exchange, MRS J is equal to MRS K. That is efficiency in exchange. For consumers, the tangential budget line and the highest attainable indifference curve ensure that, in other words, so we add competitive, right? Efficiency in exchange in competitive market, right? Competitive efficiency in exchange means MRS James is equal to PF over P clothing, right? Should be equal to MRS food for clothing Karen. So this one had it, right? That is competitive efficiency in exchange, right? And we know that this is a first order condition of utility maximization for James and Karen simultaneously, or Japan and Korea simultaneously, right? And efficiency in the use of input in production is MRTS, food production is equal to MRTS of clothing production, right? And competitive efficiency in input market is MRTS, food production is equal to W over R is equal to MRTS for clothing, labor and capital in clothing industry. And we know that this is a cost minimization condition, equilibrium condition in cost minimization of food production, right? And that is first order condition of cost minimization in clothing production, right? Achieved simultaneously. Then competitive efficiency in input market. Can you understand? And output efficiency is this one. MRS is equal to MRT, right? And we already know that competitive efficiency in output market is MRS, right? MRS for clothing is equal to PF over PC, right? Is equal to MRT FC, right? That is efficiency, competitive efficiency in output market. Can you understand? That is explained in slide number 45 and 46, right? So now we go 46. Efficiency in output market, the mix of output must be chosen so that MRT is equal to MRS for all consumers, right? So if there are two consumers, that is MRSJ is equal to MRT, MRS, K like this, right? Profit maximizing producers, so we already studied that PF, so MRT is equal to MC over, okay, anyway, I already explained. So anyway, this one is utility maximization condition, right? Utility maximization condition for consumers. So conclusion of consumer theory. Consumers produce some food, consumers consume food and clothing, satisfying this condition. Then utility of James and Karen maximized, right? That is MRS is equal to PF over PC, right? And this one is conclusion of production theory, value maximization condition, or profit maximization condition of 2 good, because MRT is equal to MC1, MC food over marginal cost of clothing production, right? Then profit maximization condition for food, profit maximization condition for clothing, right? So consumers consume food and clothing, right, to maximize his or their own utility. Anyway, consumption amount of food and clothing decided by consumers. Producers decide quantity supplied, food production and clothing production to maximize their own profit. They don't care consumers' utility at all, right? Consumers just want to maximize their utility. They choose consumption amount of to go, food and clothing. They don't care producers' welfare at all. But this condition satisfies simultaneously, led by this PFOPC. Okay? So MRS is equal to MRT. And the output efficiency conditions are satisfied. Thus, efficiency requires that goods be produced in combination and at cost and match people's willingness to pay for them. So that is willingness to pay for them, willingness to sell. That is relative price, objective price at the market. Now, that is summary of microeconomics, simply talking, right? And there are 2 country or 2 goods, James and Karen. And there are 2 consumption goods, food and clothing, production of 2 goods, QF, QC, right? And there are 2 factors, labor and capital. Then, all of these conditions satisfied simultaneously, right? So in that sense, these 3 conditions satisfied simultaneously, right? Yeah, so that is general equilibrium of microeconomics and the summary of microeconomics. Consumption of 2 goods, FJ, CJ, FK, CK decided by this one, right? And here, LF, KF, LC, and KC decided by this condition from cost minimization solution, right? And at the same time, this condition is satisfied. MRS is exchange rate from the perspective of consumers. Their exchange rate of food in terms of goods evaluated by consumers should be equal to market price of 2 goods, relative price of food in terms of clothing, right? That is market price. And MRT is exchange rate of food in terms of clothing from the perspective of producers. 3 evaluations are perfectly same, right? That is actually general equilibrium and summary of microeconomics. Okay? Now we go final section. Why market fail? Why market fail? Until now we know that if the market is perfectly competitive, then national welfare, consumers' welfare, producers' profit, and national welfare maximize automatically, led by bargain or led by price mechanism, right? So that is basic idea of free trade and market economy and Adam Smith's invisible hand story, right? So government intervention cause a problem. without any government intervention, and market function very well, nothing to worry, right? That is a summary of microeconomics. But in real world, this kind of efficiency cannot be attained automatically. Why? Because market fail. Market is not perfectly competitive, simply talking. Got it? So that is section 7 of this chapter. Competitive market fail for 4 basic reasons. Number 1, market power. Monopoly market or monopsony market. Number 2, incomplete information. Because of incomplete information, MRS, their consumers' evaluation is different from market price. Or producers' evaluation different from relative wage rate, like this. Right? And externalities, you know externalities, right? And number 4 reason is public good. We discuss each in turn. Number 1, market power. If the producer of food in our just box diagram has monopoly power, it chooses the output quantity at which marginal revenue is equal to marginal cost. And the sell less output at a price higher than it is a change in a competitive market. Okay, let's look at this. Right? Monopoly power, producers of food, for example, producers of food has a monopoly power. Then what happens? So why market fails? Section 7. Number 1, monopoly power. For example, in food production, producers has monopoly power in food production. Then it chooses the quantity. So then profit maximization condition is marginal revenue is equal to marginal cost when monopoly case instead of competitive case, right? And we know price higher than price of food, marginal revenue of food, marginal cost of food is like this, right? So this, if monopoly power in food production, then this kind of thing happen, right? Then what happen? So then production also, production of food is in monopoly power case is smaller than production of food in competitive case, right? Competitive case, right? So, and then what happens? Now think about this. The lower output will mean a lower marginal cost, low production. That means marginal cost of food in monopoly case is lower than the case of perfectly competitive one because small production, right? Lower production, right? Thus, an increase in the marginal cost of clothing production. Then what happens? L bar, K bar, same, right? L1 plus, so labor, food plus labor, clothing is L bar, KF plus KC is K bar like this. But because of this, right, lower production, smaller production, so marginal cost lower. That means more production happen in clothing. Clothing production is greater than some perfectly competitive outcome. That means marginal cost in clothing production in monopoly case greater than like this. More production happening in the other one, less production in food. So marginal cost lower, marginal cost of the other one higher. Then MRT is MCF over MC clothing, right? This one lowered, this one increased. So MRT lower than MRS, right? MRT lower than MRS. So MRS MRS is the same. But in production side, MRT becomes smaller than competitive case. In other words, MRS greater than this one. So this kind of some distortion happen, right? So that is explained here. The lower output will mean a lower marginal cost of production, thus an increase in the marginal cost of clothing production. Then the marginal rate of transformation, MRT, will decrease because MRT FC is MCF over MCC. We might end up, for example, at A on the production possible frontier in figure 16.9. Producing too little food and too much clothing is an output inefficiency. Output inefficiency happens. Why? MRT is not equal to MRS. Right? Because firms with market power use different price in their output decisions than consumers use in their consumption decisions. Okay?